Okay, in this video we have a question from Lexi asking how do we deal with these two questions? Well, this first question, if you just take a glance at it, what you notice is that you have all these positive numbers, positive 20, positive 2, and then all these negative numbers, negative 6, negative 4, and negative 10. So we're dealing with positives and negatives, and most of the time we're adding, right? We're adding here, adding here, adding here, and subtracting here. My first step in solving this problem is to rewrite it in a way that's easier to read because I have a plus and then a plus minus and a plus minus and then a minus minus, and that's not fun to think about. So let's rewrite it. We'll leave 20 plus 2, that's simple enough, right? 20 plus 2. Now here I'm adding negative 6. Well, what does that mean? Well, adding a negative is the same thing as subtracting a positive. In other words, 2 plus negative 6 is the same thing as 2 minus a positive 6. Or I can just write that as what? Well, 2 minus 6, right? Same thing. And here, plus negative 4 is the same thing as minus 4 for the same reason. And here we have a subtraction of a negative. Subtracting a negative is the same thing as adding a positive. So I can write this, instead of writing minus a minus 10, I could just write plus 10. And then now I can solve this. And this equals 20 plus 2, which is 22. And I rewrite my equation. 22, and then minus 6 minus 4 plus 10. Minus 6 minus 4 plus 10. And with subtraction and addition now, I just go from left to right. So what's 22 minus 6? Well, that's just 16, right? Minus 4 plus 10. What does that equal? Well, 16 minus 4 is 12, so we have 12 now plus 10. What's that equal? Well, that's just 22, which is my answer in this question. Now, why is this happening? Well, if we have a number line, let's just look at 2 plus minus 6. Well, if we start at 2, right here, and we add negative 6, which way do we go? Well, adding a negative goes the opposite of adding a positive. Adding 6 to 2 would hop 6 units to the right, but we're adding negative 6, so we add 6 units to the left. So we hop once, right, twice, and then 4 more times. 1, 2, 3, 4. And I should extend this number line. And that brings me all the way down to what? Well, negative 4, right? 1, 0, negative 1, negative 2, negative 3, negative 4. So that's the same thing as saying, well, what's 2 minus 6? Well, you start at 2 and you subtract 6. You go 1, 2, 3, 4, 5, 6 units to the left, and you end up at negative 4. So to recap, in this problem, we just rewrote it in a simpler format, and then we solved it. The next problem with fractions, we're adding negative and positive fractions. When you add fractions, you should leave the denominator the same, especially if they're equal. So this will be in terms of eighths, right? And here we have a negative 5 plus 7. So you can think of this as negative 5 plus 7. And what's that? Well, that's the same thing as 7 minus 5. That's over 8, which is just equal to 2 eighths. Oops, 2 eighths. You can reduce that, divide both numerator and denominator by 2 to get 1/4, and that's our answer. So a basic strategy for adding negative and positive fractions, especially if the denominator is equal, is just to assign the negative sign to the numerator here and treat that as if it's negative 5 plus 7. And that's just 2, right? If you think about a number line there, you have a negative 5, and you add 7, you go up 7. 1, 2, 3, 4, 5, 6, 7. And what's this mystery number? Well, negative 4, negative 3, negative 2, negative 1, 0, 1, and then 2 is the answer, which is the same thing as 7 minus 5. Because you can reverse your digits, right, in addition. So this becomes 7 plus negative 5. And that can be simplified to just 7 minus 5. That's almost the same strategy we used here with 2 plus negative 6. We rewrote that as 2 minus 6. So 7 plus a negative 5 can be rewritten as 7 minus 5. And let's just try another one with the fractions because that throws a lot of people off. So what if I have negative 2/3 plus, I don't know, negative 1/2. So first we should rewrite these fractions so that we have a, what's it called, a least common multiple in our denominator. So 3 and 2 go into 6. So I multiply this by 2 and by 2, and I get negative 4, right? Negative 2 times 2 is negative 4, over 3 times 2, which is 6. And then here I multiply both numerator and denominator by 3, right? Because I'm trying to get this in terms of sixth. So negative 1 times 3 is negative 3. Over 2 times 3, which is 6, now I can add these. So once the denominators are equal, that's our number of sixth. And we have negative 4 plus negative 3. If we add all those negatives, we get negative 7 over 6, and that's our answer. Alright, so I hope this helped.